Hi, I think all of you are enjoying studies. So let's see next again differentiate between two terms, that is uniform motion and non-uniform motion. Now what is uniform motion? A motion in which, see, when object covers equal distance in equal interval of time. See, a motion in which object covers equal distance in equal interval of time. Such a motion is called as a uniform motion. So what is the definition for non-uniform motion? See, non-uniform में खाली instead of this equal distance के बजाय unequal distance, otherwise definition as it is. So what will be the definition for non-uniform motion? See, when object covers unequal distance in equal interval of time, दोनों साइड interval of time same रहेगा. Only changes the what? In uniform motion equal distance will be there, and in non-uniform motion unequal distance will be there. So this way a definition of both of this one. Next, the second point, we can say that a graph of uniform motion and non-uniform motion when we are drawing. So you can see a graph is like this one, time against distance or distance against time. In such a situation, a graph of uniform motion is always straight line. A graph of uniform motion is always straight line graph. And for a non-uniform motion, the same graph is not straight line. So the second point is like this one, a graph of uniform motion is always in straight line, and second point in the non-uniform motion is a graph of non-uniform motion is not in a straight line. Let us see example of both of this one, uniform and non-uniform. This is an example of uniform motion and non-uniform motion in our textbook. See, they have given Amar, Akbar, Anthony were three friends. They travel from their own vehicle and they decided to calculate or note down a distances covered after every half an hour. After every half an hour they were counting a distance and their readings are given over here. Now you can see in the case of Amar. Amar started a vehicle at a 5 o'clock. So initially he was in a rest, not travel, that means a distance is 0 kilometer. But after half an hour at a 5:30 he traveled 20 kilometer. 6 o'clock the total distance was actually 40 covered by him, but within this half an hour यानी ये 5:30 से लेकर 6 बजे के बीच में इसने टोटल डिस्टेंस कवर किया है 20 ओनली. 6:30 को टोटल 60 था, 7 को 80, 7:30 को 100 and 8 o'clock 120. If you see the Amar's example, after every half an hour, हर एक आधे घंटे के बाद उसने 20 डिस्टेंस कवर किया है. So in short, Amar travels equal distance in equal interval of time. But you see in the case of Akbar, started a vehicle, so in a start initially is a what 0 distance traveled by him. आधे घंटे के बाद 18 किलोमीटर, उसके आधे घंटे के बाद और 18 यानी टोटल वॉज 36. नेक्स्ट 6 किलोमीटर ही ट्रैवल टोटल दिस वन by him within that half an hour, but the total was 42. Next total was 70 actually, but if you see the difference between this, it is a 28 kilometer travel by him within that half an hour. यहाँ पर देखेंगे 25 total, actual total travel by him, total was 95 and total here is 120, and actual it is, if you count it is a 25. So if you count कभी 18, कभी 6, कभी 28, कभी 25, कभी 25. In short, Akbar travels unequal distance in equal interval of time. Now in the case of Anthony travels, you see, पहले स्टार्ट में रेस्ट में से स्टार्ट किया 0, then he travel 14 किलोमीटर. Next, total was 28, but actual within that half an hour he traveled 14. Again 14 kilometer, total was 42. Next, total was 56. Actual he traveled within that half an hour 14. Total is 70. Next, and actual is the 14. Total was after 8 o'clock. Total was 84 kilometer by him, but actual 14. In short, Anthony travels 14 kilometers, 14 kilometers after every half an hour. Means Anthony covers equal distance in equal interval of time. So, in this example, Amar and Anthony's motion is a uniform motion, whereas Akbar's motion is non-uniform motion. Next quantity we are going to see is the acceleration. What is acceleration? Rate of change of velocity. Rate of change of velocity is called acceleration. So guys, see, the word rate of again came over here. Rate of means divided by time. So if I want to make a formula for acceleration, so I can say to you, so acceleration is equal to change of velocity upon time. As you see, the rate of word is there, so in a formula divided by time. Now whose rate of change of velocity? So see, the formula is becoming acceleration is equals to change of velocity upon time. If a guy's change of velocities are there, then there must be two velocities, that is initial velocity and final velocity. So you see, acceleration is symbolized by A, and when I am mentioning arrow on it, that means you better know now it is a vector quantity. Now change of velocity is a what? Final velocity minus initial velocity, because as I said to you, two velocities are there. So if you want to see the change, so we need to see the difference between them. So final velocity minus initial velocity is a change of velocity. Time is symbolized by T. For a final velocity we have a symbol V. V is a vector, velocity is a vector. Initial velocity is symbolized by U. It is also vector. Any velocity is vector. So very finally we can say that A is equals to, acceleration is equals to V minus U upon T. This is what formula of acceleration. Types of acceleration is two. One is uniform acceleration and another is non-uniform acceleration. You see, in the definition of acceleration we said that rate of change of velocity. That means acceleration depends upon change of velocity. So while I'm making a definition for uniform acceleration, we can say it like this one. If change of velocity is equal in equal interval of time, then that acceleration is called uniform acceleration. Whereas in non-uniform acceleration, if a change of velocity is unequal in equal interval of time, interval of time remains same, then that acceleration is called non-uniform acceleration. If anybody asks you to differentiate between these two, so first point is definition. Now what will be the second point? For a second point, you just keep in your mind, whenever any term is uniform, okay, then the graph of it is always straight line graph, and for a non-uniform, graph is not in a straight line. Units of acceleration. See, SI, that is MKS unit of acceleration is meter per second square. Meter per second square is a SI or MKS unit of acceleration. Whereas CGS unit of acceleration is centimeter per second square. Centimeter per second square is the CGS unit of acceleration. Now we are going to discuss some important topic as exam point of view. As you see, acceleration having a formula V minus U upon T, whereas v is equals to final velocity and u is equals to initial velocity. Now there might be a 3-mark question or maybe 1 mark questions. When acceleration is positive, when it is negative, and when it is 0. So what is the answer behind that? See, it is like this one. When initial velocity is smaller than final velocity, that is when velocity increases. When velocity increases, then acceleration is called positive acceleration. But if you see, when initial velocity is greater than final velocity, that means when velocity decreases, then that acceleration is called negative acceleration. And such a negative acceleration is also known as deceleration or retardation. Deceleration or retardation. Negative acceleration is also known as deceleration or retardation. Very final is a what when u and v is the same one. That means initial velocity and final velocity is same. That is, velocity is uniform, velocity is unchanged. In that situation, acceleration is zero acceleration.